we have a next speaker, and I'm so pleased to tell that this is really famous person among project managers, especially among PMI members. And my pleasure is that my ex-colleague, unfortunately not a colleague today, but the life is life, so okay. It's Roman Reznikov. It's a head of digital segment at Intellias. And this year, Roman is the president of PMI Ukraine chapter. And moreover, if you would have a look at the 7th edition of PMBOK, you would be able to find Roman among contributors to this edition. So this is a person who knows everything about what is new in project management. And today, Roman joined us. Thank you very much, Roman, and welcome to the conference, to share with us some new concepts, new innovations in data-driven decision-making. So, hello, Roman.
Hello, Denis. Hello, everyone. Thank you very much for this introduction, and I'm really happy to be here again in this room. I've spent like for five previous years, happy years with SoftServe. Yeah, my name is Roman Reznikov. Today I'm going to tell you a bit about data science, data mining, and actually like different data analysis approaches that you can use in project management, and I used those frameworks in my personal, like those projects that I have in my portfolio. A few words about my current work. I supervise the portfolio around 40 different projects. It's about 450 people with clients from US and Europe in different domains like education, e-commerce, retail, healthcare, and many others. Like those are list of some of my recent achievements. So overall, I'm like about 10 years in project management, a little more than that, and I think most of the interesting facts about me, Denis already mentioned. So, given the context, what we are going to talk about today, I have to specify that probably some of the practices that I will share, they will not be like applicable for all projects, as like my core experience is like with software development projects. I build those practices out of them. So you may try to apply them in construction or any other industries, but like the key idea of today's session is that we are going to talk about software development projects. And as my experience is mostly related with service companies like Intellias or SoftServe, we will talk about the projects as an external project. Definitely you can look at like project as some like internal endeavor, but most of the projects in my career were the projects that we did for our clients. So we'll have kind of vendor, service company, where I usually were part of, and the client who actually take those value that we deliver for them. And also another area that you need to consider that most of the practices that we will go through today, they will cover scale 40 plus people. So if you have a small Scrum team, probably that would be not very useful information for you. You can just take a break before the next speaker or take a coffee. If you work with, or you're going to work with the scale 40, 60 and more people, some of the practices that I will share today will work for you. Also, just like quick spoiler, like I will not give you a silver bullet here. So this is just a approach, a mindset that you can follow, but how to implement this, what metrics or what data to analyze, that is fully up to you, and you will need to decide it based on your portfolio. So why are we talking about data-driven approach and data-driven decision making? I usually like split like approach that we can follow managing projects or any other engagement in two different types. One type is so-called smart user, where all of the decisions are made by the manager. So you as a smart manager, you think, okay, what we can do in order to keep this project on track, or this engagement track. Other area is so-called data-driven approach. It needs to be approached in the cases where the decisions are not that much obvious. Like simple example, for example, if you have one team and you need somehow measure the performance of the team, it's very easy to talk about the performance in terms of velocity, the number of the story points this team does during the one sprint or iteration. However, if you have multiple teams like 5, 6, 7, you need to acknowledge that estimation in one team may vary significantly from estimation in another team, and so you never can compare like story points in different teams. And you need to think about some more sophisticated way how you can track the performance of the whole portfolio, or how can you predict the release results for different teams if you like need in outputs of their work in order to assemble everything together. So in this case, where it's not that straightforward, going to the data layer may help you to make those decisions. Like simple case here on the graph is actually like the strategy for Trump's election, like first Trump election where he won Clinton, where according to like most common sense data, he's supposed to lose, but smart analysis of the situation helped him and his team to define the right strategy and won that election. So that's one of the sample where like just smart user approach wouldn't work, and data helps to make right choices and build the right strategy. Why smart user approach not always work? Because we are human beings, and usually we do some kind of mistakes. We have a bunch of different biases which usually impacts our decision-making approach, what we do, how we do, why we do those stuff. There are a bunch of them, you know, like for example, one of them, it's called the K effect. When you do something by your own, you always give more value to this. It's a good sample for the companies like SoftServe, where like there are a huge amount of homegrown tools, while there are like similar tools on the market. And to make smart make or buy decision, it's very hard, because everything that you did by your own, you feel that it has more value rather than you just buy it from the market. So this is like one of the biases, and whenever you run a full make or buy analysis and analyze all data that you have, you may see that it doesn't make sense in most of the cases to write something on your own. It's better to buy ready-to-go product. And this is one of the samples. Actually, there are quite many of them, and all of those biases, they really impact those decisions that are made during the project management or when you work with the large portfolio. On a small scale, it has not that large impact, so you have ability to make some corrective actions, but on a large scale, it may bring to like very sad results. One good sample, and actually this is my favorite report from Jira, it's called version report. I usually cheat a bit Jira, so I assign versions not according to those like version control approach that we use on the project, but I assign all tickets to one version, and it gives the ability to build very precise report like this. What it does, it just analyzes the performance of your team for the past at least 3 sprints, but the more you work, the like better precise result you have, and it predicts the release date based on your current performance. So let's imagine that you have right now in your backlog 100 story points, and during the past 3 months, your team does 50 story points. So most likely for the next 3 months, you will do another 50 story points. It's just like statistic. And you know, like if you sit together with your team and try to estimate your schedule, you may come to different days. It might be 1.5 or more story or more months. But this is kind of the reality, and it's very hard to cheat this this report. So from my personal experience, it's very precise until you do the same type of the estimation during the whole course of the project. So this is the sample how data may help you to identify the release date based on your current backlog and based on the information of the performance of your team. But this is like sample from the box, something that you have in Jira. Usually when we talk about large projects, large engagements, we might face the situation where we don't have required tool or required report or required analytic right from the box. We need to build it out our own. And here, like I usually take as a sample common data flow in any enterprise organization. So we have a set of sources of the data. So it could be ERP, CRM system, or any other system. We have data warehouse. We work with the data. We store them, we structure them, and we create data marts, so set of data that are focused for the specific group of users. And we have actually some BI tools that help us to build analytic for the specific users. So that's how it works in a nutshell. And when we talk about this data flow for the project, which is also kind of small endeavor, small enterprise, we can actually use the same approach. Let's start with the users and analyze what data needs to be presented to which group of users in order they can make smart and wise decisions. I usually divide in the projects I mentioned, like software development project, where we have a vendor and we have client. I divide it into like different groups, which is internal and external group of users. Also, I split it into 3 different layers. One layer is like team layer. Then we have like management layer, and then we have upper management or C-level. If you look at specific roles for the external, for the client management, for the client stakeholders, client users, upper level might be presented by C-level or vice president level. We usually have some engineering manager and basically team leads inside of the team. On our side, we usually have project manager. I usually treat project manager as a part of the team, so it's on the team level, delivery director or any other type of the role equal to this, and also VP level. And we have different types of the report that we can build for those group of the stakeholders. I usually divide 2 group of report or like 2 group of data that we can provide to them. Like one of them is like real life dashboards that we can build and they change in the real time. Usually they have a lot of details and they're required exactly to make those wise decisions and like do the mining of this data. Another type of the data that we can present to our group of stakeholders are different kind of reports. So this is the static data. So usually it's like Word or PDF or PowerPoint presentation with a specific set of data that are relevant for the specific date. So we usually provide it for the upper level stakeholders who are not really interested to go to the Power BI or any other tool and look to all those numbers. They just see the summary. There is a third type of data, which is a third type of the outcomes that we can get out of this data analysis, which is exact recommendations. So what we can advise or some like decisions that can be made analyzing those data that we have. But to be honest, like for the past 10 years, I've never seen this really implemented in the full-fledged on any project. So usually like those 2 types that I mentioned before are the most relevant. If we compare data relevant for like project manager, team manager, and portfolio manager, they would have like a bit different view. For the portfolio level management, they're not really interested how many story points you did during the sprint or what's the velocity of the team, number of the bugs. So usually high-level stakeholders, they're not interested in that much details. So they need some high-level report and basically see the list of the projects or engagements and some areas and just traffic light. In most cases works fine. Other types of the report might be financial report, but in general, if you talk about project health, that's the way how they would like to see this report. But for the project level, we need to go much deeper and we need to understand, like analyze different set of data to see any deviations and any insights which may help us to improve the situation with this particular project or somehow fix some problems or identify some negative trends. So there are a couple of data mining techniques that might be applied for this kind of data analysis. One of them is anomaly detection. It works very well specifically for the support projects, or for example, if you choose Kanban board in Jira, you may build so-called control chart, which put on a one-time scale the lead time of that you spend to fix different types of defects in your or tickets in your project. And by this, you can actually identify that most of them, they're supposed to be around like specific threshold that you specified for your project, but there might be some that are really deviate from this command line. And you can actually work with your team analyzing those deviations and understand why it's so, why we have those deviations. Maybe something went wrong and we need to make some kind of correction actions. It's very important for the support projects, for instance, because usually like we have some strict SLA and those kind of deviations might mean some penalties for us as a team. So that's quite important. Also, we can analyze so-called outliers, wherever we have any set of data and we see that most of them, they might be grouped in some kind of cluster. Probably there are some of them that deviate from these clusters, and we can also analyze them and understand the reason for this. It might be that we have some anti-patterns that we can fix analyzing those set of data, as well as like look to some training. So for example, we can see that the performance of our team constantly growing, But from another side, we need to analyze maybe it's not the growing performance, but inflation of the story points that we have. And we can actually work with the team to understand where we are, are we really doing a great job, or maybe we just need to make some adjustments in the processes we have. So that is just few samples. Actually, there are many more. You can investigate them. Some of them you can do manually, like you can just take the set of data to look at the graph and make some decisions. Some of them might require you to build some machine learning model in order to find this deviation, those sets. So it might be a bit more sophisticated. And basically, the bigger scale you have, the harder for you will be to analyze this set of data. Okay, so we analyze that we have different group of stakeholders from like internal, external. Both of them, they require to make some kind of decisions. Also, we understand that we have different types of the reports. It might be live dashboards, it might be static reports. And the next question is how to build them, actually. What the tool we can use in order to build those kinds of reports. So there are multiple tools on the market. My favorite are Google Data Studio, which is free, and actually it's a very powerful tool, very easy to use. You don't need to like learn or like, have very strong technical background. It's like very intuitive. We have also Power BI, quite common tool, and it's very good. It has very good integration with multiple other tools, especially in Microsoft ecosystem. We have Tableau, which also great visualization, very convenient to use. Some of the companies, they have their own homegrown tools. I know that EPAM has their own tool to analyze data. Software has metric collection tool, which also helps to build this kind of analytics. But still, there are quite many tools on the market that you can use and build those dashboards for you. Now let's look at another side of this diagram. So we analyzed how to build those reports. What are those reports like? They need to be done for a different group of stakeholders. What to show on that report, it still remains up to you, because all projects are different and there is no like rule of thumb that you need to show this, this, and this. However, let's look where to collect the data. And until the previous part were like quite generic in terms of you can do this for any project, not only software development. But this part will be like mostly focused for the software development world. So there are two main sources where you can get data for software development project. First is task tracking system, for example, Jira. Another is repository, for example, GitHub, but it could be also like Bitbucket, GitLab, and any other. There are like a couple of different layers of the, in order to collect data, you need to have process which generates those data. There are like different layers of the maturity of those processes, which helps you to collect and analyze specific set of data. The most easy way to analyze data and like the first layer is actually just issue count. For example, you know that in your project you have 20 user stories, and basically you can work with the data. So you have 15 in your backlog in to do, 5 in progress, and 0 done. So more or less you can understand your throughput. You can build some kind of lead time. So just pure issue count will give you already a specific set of the data that you can analyze. But it's very simple. And the next layer, what you can do with this issue count is actually to analyze different stages for each ticket, for each issue. All ticket systems like Jira, Trello, or any other, it has pretty the same flow. It has you can build it, customize it, but in general it's like to do in progress done. But usually in progress or even to do, you can split into multiple areas. So it could be like analysis, development, testing, and so on and so forth. So there might be multiple of them, and you can actually analyze those data as well. For example, how many tickets you have in each stage in the specific moment of time, or how long each ticket stays in this specific field. So this is like another layer for you, and the more incremental you have this flow of the ticket, the more data you have and the better understanding you have where the ticket is right now, what do you do, why it stays for that long time in the specific field. So that's pretty useful set of data. Another area that you can analyze is actually different kind of issue types. So you may have just one ticket, and that's it, but you can actually split it, for example, to have user story, which is some functionality, and defect or bug. And you can also analyze those comparisons. For example, how many defects you have comparing to the user stories, or any other issue types if you have in the backlog. So this is another layer, more sophisticated, and which gives you another bunch of data. The next layer is actually assignee. Even the simple task tracking system allows you to assign specific ticket to a specific person. So you can analyze, okay, how many user stories done by each developer, or how much time each developer worked on the same size user story. So that gives you another layer how to analyze those issue count based on assignee. And also, like Jira and other task tracking system, they allows you to create different labels or components, and based on that, you can actually also filter and build some analytics regarding each data. For example, you can somehow tag your tickets with the technology that is used for delivering this feature, or like area of your product. So it could be like SAP, Salesforce, or anything else. And you can basically understand how many tickets in each category you have. And that might also give you some insights on the process that you have on your project and how that might be optimized. The challenge with this issue count is that we work with the assumption that all issues, by issues I mean any type of ticket you have in your system. It could be user story, it could be defect, but we're working just with this count. We work with the assumption that all of them are equal in terms of size, and in most cases not like this. For example, you may work on issue count, for example here on the graph, we have 40 issues done within release number 1, which is 25% from general issue count. So we have in general 158 issues. However, those 40 is almost it's 42% of the whole scope. We know this because we estimated each user story, and we realized that one of them was small and others are big, and basically having understanding of their size gives us another layer of preciseness, of certainness. There are different approaches. I try to analyze different frameworks in terms of whether those estimation gives another layer of preciseness in terms of collecting of those data or not, because on the big numbers, even the issue count gives pretty good results. But the big benefit of this exercise is that you need to run estimation. This is kind of another part of ceremony within your team. It could be done in scope of planning, or it could be a dedicated session, and that gives you ability to compare plan and fact. So you build some kind of forecast. Your team is working on building some assumption about the future, and then you can actually compare it with the real result. So it's very important because sometimes it gives a commitment to the team, and for you it's always also quite important to understand how a team can precisely estimate the real complexity and time needed to spend to deliver a specific feature. So it's also very healthy and useful to analyze the data. So estimation and story point is another layer of data that you can collect. So now we have issue count, just pure number of tickets that we are working on, and their different types, assignee, and so on and so forth. And also we have story points. The third layer is actually estimation in hours, or at least not estimation, but reporting of the hours. I think estimation in hours is not always efficient in software development type of the projects, but the reporting of the time to the specific issues gives you very good understanding of how much time already spent on different types of the activities. And having this layer, you may do some kind of triangulation, which is kind of analysis of different aspects of the project. So you can estimate, you can analyze data in hours, you can analyze data in some complexity points like story points, and you can analyze the pure issue count. So this 3 dimension gives you ability to collect many different metrics, which may be very insightful how to work with them. You can actually add to this many more layers. For example, financial layers. So you can say, okay, we each piece of work, it's also a specific amount of money or value that we deliver for our client, and we can also add this to the system. So the more data you have about each ticket you work on, the more deep analysis you can run, and like the more interesting insight you can actually generate out of this data. And when we have all this set of data, we usually face that tools that are already in the box, for example, in Jira, in Azure DevOps, and another task tracking system is not enough to analyze them. We need to grab this data and visualize them in some third-party tool, like I showed previously in Google Data Studio, Power BI, and so on and so forth. Because like in pure state, like just the number of the story points or just the number of the issue counts, it's not very much insightful. Their combination, they're just like, when we compare them somehow between each other, they might give us some insights about the work. And that's very important, you know, to build this middle layer between BI tool and between the source. This in between layer, like for example, the simplest way could be an Excel file. Like not many people use it, but Excel has a built-in feature to grab data, for example, from Jira, and every time you open this Excel, it will grab the latest snapshot of the data from Jira, and you have some built-in functionality. You can actually tune some formulas to build specific reports for you out of this data, and then you can actually export them to some like other tools. So this is just like simple case how that may work, and there are like multiple other implementation. Another good area for the analysis is actually repository where the code is. Actually, this is the place where the magic occurs. So sometimes this source of data is like ignored on many projects. People usually like project managers usually look more in task tracking system, but actually out of here, out of repository, you can get much more precise data. When developers started work on specific feature, when it was delivered, when the commit was sent to the pull request, and so on and so forth. So like there are a bunch of information that you can get out of repository, and you can compare two different set of data out of task tracking system and out of repository, and basically based on these two set of data, you can get much more precise information about what's going on and build much more precise estimation or forecasting or just finding some deviation. Also, repository is a great source to analyzing the quality of the work. Here is very helpful tools like SonarQube, which runs static code analysis, and you can actually see different quality metrics like code smell, code duplication, and others, which also may give you some idea about code quality, and you can somehow combine it. For example, one of the samples I had in my experience, we worked on one client comparing competing with one Indian vendor, and our team always showed worse performance than their team, and clients got concerned because like our team were more expensive, and they saw that they did less story points than this another team. However, we tuned this SonarQube, and we start looking not only into performance but also into the quality metric, and we built a metric which multiplies the performance in the story points into the metric called code smell from SonarQube, and we saw that despite they have very high performance, the quality of their code is super low, and basically then they need to spend another sprint to fix the quality of the code that they did in the previous sprint. So just looking into the performance, it looks like our team is underperforming, but when you look in the both metrics in quality and performance, it becomes obvious that actually our team did much better job than they do. So that is just the sample how analyzing repository and task tracking system may be combined and bring some insights. Most of the GitHub or GitLab, different type of repos, they don't have very much advanced analytic. However, they have APIs, so you can actually grab those data to Power BI and other tools and build some fancy reports that might be useful for you and for your management. And yeah, so let's just summarize. We have sources of the data for software development projects, which is task tracking system and repository. We have tools to visualize the data, which is Tableau, Power BI, and Google Data Studio. And we have this place in the middle. What's in the middle, how to take those raw data out of those systems and visualize them in a very nice and fancy way, that's my secret sauce. So we're not going to through this part on this session, but if you're interested, feel free to drop me a line on LinkedIn, and who knows, maybe I will share with you some of my secrets. That's all from my side. Thank you very much, and see you again.
Okay, thank you very much, Roman, for this really practical speech. I believe our viewers got a lot of insights and useful recommendations. We have a number of questions, if you don't mind.
Sure.
One question is really challenging, if you don't mind.
Absolutely.
Can data-driven approach lead to wrong decision, or just worse than smart user approach?
Yeah, so that's a good question. Working with the data is always working with some hypothesis. So you do some hypothesis that specific set of data will bring you to the specific result, and it's always an experiment. And I would say especially in the beginning, when you're just building this data model, in most of the cases, you will find that it's not going to work. I mean, you may find that some results is not relevant to what you have. So you need to keep those experiments and find those set of data that leads you to the specific insightful decisions. So yes, if you just start doing this exercise, just start building this model for your project, most likely you will get some data that will lead you to the wrong decision, or just those decisions that you might feel wrong. But with the time, keeping those experiments, you may build this model very precise, and it might become more insightful. So my answer is yes. In the beginning, it definitely will happen. But what I suggest doing is actually combine those two approaches, like smart user and data-driven. Data-driven is like some data that might help you to make your decision even more smarter. But as our clients from UK call this like a tool with a fool with a tool is still a fool. So wherever you have something but you don't know how to use it, it will not help you a lot. So even data-driven decision requires like smart user above this. So that's my answer.
Okay, thank you very much. Another question is, have you ever tried or seen implementation of artificial intelligence or machine learning in project management?
Okay, that's a cool question. To be honest, I've never seen like working approach, like working mechanism on real life projects. However, I do remember we tried a couple of pilots. I saw several startups which provide some kind of decision-making engine or some AI-driven scheduling tools. I probed them. To be honest, haven't seen big value so far, but I assume that might appear somewhere in the close future. Just it's not so broad implementation, and most of them, they're more informative of the startups. So I can't say that I've seen something really valuable there. But there were like a couple of interesting ideas, and I think in like some close future that might be implemented, especially if some like big giants like Oracle with their Primavera or Microsoft project might like start using this in their product. So I think that has potential.
And the last question, all the managers are always looking for this silver bullet, the pill that solves all the problem. And talking about the KPIs, what is the most important KPI or metric for the manager in order to keep the project alignment on track?
Mm-hmm. Like with those projects that I usually deal with, I would say that client satisfaction is like one of the key metric. And how to achieve this client satisfaction is a good question. We have multiple stakeholders and we need to understand their expectations, but just measuring how client is satisfied with what we do, I think is like the core for the software development projects that we usually do for our clients. Sometimes our clients is the users of this product. Sometimes like they have their own users, so we really much depends on satisfaction of that users. But I think the key metrics in any projects is about people and satisfaction of the client, satisfaction of the team is, like, from my perspective, the most crucial metrics that we have.
Okay, as long as we have a little bit more time, we can ask one more question for you, if you don't mind.
Absolutely.
The question is following. Since each story point represents a normal distribution of time, what is the reason to use story points for the estimation?
Okay, that's a very cool question. From my perspective, that's a very wrong approach when we try to equal story points to some measure of time. So when we say, okay, let's call one story point is 1 day, and let's try to measure somehow our backlog and story points instead of days. So the approach I usually suggest is use story points only like measure of comparison one user story to another user story. So if we have a set of 10 user stories in our backlog, we may say, okay, the most complex one, let's call it like 10 story points, and the simplest one is like 1 story point, and all in between it's somehow distributed between those ones. But don't try to estimate in hours or days and then convert this to the story points. Better do this vice versa. So estimate the complexity. Complexity should be estimated in comparison. So just like have like couple of buckets, like small, medium, large user stories. Compare those user stories between each other, and then you can retrospectively analyze how, in average, it takes your team to accomplish like 3 story point user story, or like 1 story point user story, and you may somehow measure this, like make this parallel between number of story points and days. But like my suggestion, you can do this, try to do this retrospectively, but don't try to estimate in this way. Don't try to estimate first in hours and then convert this to user stories just to call 1 day 1 user story. That doesn't make too much sense.
Okay, thank you very much for this answer, and also want to thank you very much for joining us today and sharing this really practical and really insightful recommendations how to use the data and what sort of data, using which tools, and all this with our visitors. Really appreciate it.